Hello students, welcome to the second video lecture of physical world. I left you people at unification in the last video lecture. That was the first approach in physics. Now we will proceed with the reductionism, that is the second approach in physics. Okay, let us understand the reductionism. To understand or to derive the properties of a bigger or more complex system, the properties of its simpler constituents are taken into account. This approach is called reductionism. It is supposed to be the heart of physics. So it is very clearly written over here that a bigger system can be understood on the basis of its simpler constituents. So we can say that if a bigger system is explained in terms of its simpler constituents, then this kind of approach in physics is called as reductionism, right? Example of reductionism: a complex thermodynamical system can be understood by the properties of its constituents like kinetic energy of molecules and atoms. It means thermodynamical system is a bigger system, or we can say the complex system, and its constituents are what? Internal energy, okay, potential energy of molecules, kinetic energy of molecules, and its atoms. Okay, so when we explain the thermodynamics in terms of kinetic energy, or we can say internal energy of its molecules and atoms, then this kind of approach is called as reductionism. The meaning of reductionism is hidden in this word only. Reductionism has come from a word that is called as reduce. Okay, so to reduce a complex system in terms of its simpler constituents, okay, is called a reductionism, right? Next. Now let us come to the domains of physics. Domains means regions, mainly which regions the physics works. So there are two main regions in which physics works, that is macroscopic domain and second is microscopic domain. Here a word macro and here the word micro explains the property of these domains, right? Macro means bulk, micro means very small, or we can say minute. Let us proceed. Macroscopic domain includes phenomena at the level of laboratory, terrestrial and astronomical scales. It means bulk scale, right? When the phenomena is explained at bulk scale, or we can say the related experiments are performed in the laboratory, which we can see easily, we can observe easily. So that kind of domain is called as macroscopic domain. But microscopic domain includes atomic, molecular and nuclear phenomena. It means it is explained at which scale? Minute scale. I discussed it earlier when I was explaining these two domains, that micro word means what? Minute, very small. So when a phenomena is explained at minute scale, okay, atomic or molecular or nuclear scale, then that particular domain of physics is called as microscopic domain, right? Recently, third domain in between is also thought of with the name mesoscopic domain, but we will not consider mesoscopic domain over here. Mainly we have to study macroscopic and microscopic. Okay, this mesoscopic domain deals with the group of hundreds of atoms. It means if so many atoms we consider, okay, so it comes between the macroscopic and macroscopic and microscopic, that is called as mesoscopic domain, right? Next, scope of physics is very wide and exciting because it deals with objects of size as large as universe, 10 to the power 25 meter. You can see universe is very large, there is no beginning, there is no end. So scope of physics is very wide. It starts from universe and it goes up to a very minute scale, that is 10 to the power minus 15 meter, that is nuclear scale, right? So you can see a very large range of scope of physics. Okay, right from 10 to the power 25 meter to 10 to the power minus 15 meter. Okay, this measurement is also called as 1 Fermi. Okay, 1 Fermi is the unit of distance, and very small unit, that is 10 to the power minus 15 meter. Right. Next, let us come with the excitement of physics. Means what excitements physics produces. So live transmission through television, this is one excitement. Another is computers with high speed and memory, use of robots, artificial intelligence, you must be knowing about this, lasers and their application, right? So many excitements of physics are there, but I have discussed few only, so you can cope up with these particular with other excitements also by understanding these excitements, like light transmission, computers with high speed and memory, use of robots, laser and their applications. Okay, next, now the next topic is the fundamental forces in nature, right? What are fundamental forces? So mainly we discuss the 4 fundamental forces in nature here, but first of all let us understand what are the fundamental forces in nature. There is a large number of forces experienced or applied. These may be macroscopic forces like gravitation, friction, contact forces, and microscopic forces like electromagnetic and interatomic forces. But all these forces arise from some basic forces called fundamental forces. It means different kinds of forces we observe in our general life. Okay, some are macroscopic forces, some are microscopic forces, but these forces come from these forces come from mainly 4 fundamental forces. They are categorized on the basis of fundamental forces. Okay, so that we are going to study which kind of fundamental forces are there in nature, right? So the first fundamental force is what? The first fundamental force is gravitational force. You must have understood, or you must have gone through the universal law of gravitation in class 9th, right? So we are talking about that gravitational force only, which we have studied over there in class 9th. So what is a gravitational force? Gravitational force already we have studied, the force which acts between any two bodies in the universe. Okay, attracting force which acts between any two bodies in the universe is called as gravitational force. So what are the properties of gravitational force? Let us go through. The first one is, it is due to mass of the two bodies. Definitely you must have gone through the formula, F is equal to G m1 m2 upon r square. So masses are involved, so that's why it is due to the mass of the two bodies. Second, it is always attractive in nature, we have already studied. Third, it operates in all objects in the universe. I have used this particular word in my definition just now. I have given the definition also of gravitational force. Next is, its range is infinite. Earth and sun, distance is too large, but then also this force is acting, so that's why its range is infinite, very large range force. Next is it's a weak force. It is 10 to the power minus 38 times compared to strong nuclear force. Strong nuclear force is another fundamental force. We will study it further, but here I can say this statement of the meaning of this statement is what? The gravitational force is a very weak force. Okay, weak force. Why? The table and the chair, they are placed, the gravitational force is acting between them, but it does not appear. Why? Because it's not very strong. It does not mean that between table and chair there is no gravitational force. Gravitational force is there, but by nature, since it's very weak, so that's why it does not appear over there. Okay, that's why it is called as which kind of force? Weak force. So these are the properties of gravitational force. You can go through and note it down. Next fundamental force is electromagnetic force. Electromagnetic force, example, you must have gone through the Coulomb's law in class 10. It is not given in the syllabus of class 10, but a little bit introduction is there of Coulomb's law. That the force which acts between the two charges, electrostatic force of interaction which acts between the two charges, okay, by nature it is which kind of force? Electromagnetic force, okay. It was expressed as F is equal to K Q1 Q2 by R square, right? So this is one of the example of electromagnetic force. So what are the properties of electromagnetic force? The first property, it's due to stationary or moving electrical charge. F is equal to K Q1 Q2 by R square. This force F, or we can say the Coulombian force, or we can say the electrostatic force of interaction, always valid for what? Which kind of charge? Static charges, okay. So it can be between the stationary or it can be between the moving charges, right? Second property, it may be attractive or repulsive. The electromagnetic force may be attractive or it may be repulsive also. For example, if both the charges are of same nature, if both charges are negative, which kind of force will be there? Repulsive. If both the charges are opposite in nature, it means one charge is positive, another is negative, which kind of force will be there? Attractive force, right? So that's why it's written over here, it may be attractive or repulsive. Third, it operates on charged particle, right? So for the electromagnetic force, the charged particles are needed. Next, its range is infinite. It is a very large range force, okay. It depends on the magnitude of the charge, okay, and all that. So that's why it's which kind of force? Large range force. Next property is what? Electromagnetic force is stronger. It's 36 10 to the power 36 times stronger than the gravitational force. Sorry, it's not written correctly over here, but this electromagnetic force is 10 to the power 36 times stronger than which force? Gravitational force, but 10 to the power minus 2 times stronger than, or we can say 10 to the power minus 2 times weaker than which kind of force? Strong nuclear force, right? Power is negative, so that's why it's weaker. Strong nuclear force is another fundamental force. I told you before this also that this force we will study further in the next video session, but for your this time as an information that the electromagnetic force is stronger than which force? Gravitational force, but weaker than which force? Strong nuclear force. So up to here we have studied the fundamental forces, two fundamental forces. First was the gravitational force and second was which kind of force? Electromagnetic force. Now in the next video session we will study the other two fundamental forces. One is a strong nuclear force, another is weak nuclear force, okay, and at last we will study the conservation laws. So all the best to everyone, those who are watching these videos. Keep on working hard, keep on studying, keep on revising, keep on elaborating. Thanks a lot.